5. And then really it's t plus c in parentheses or minus c. We'll get to that. Plus 3 here. Okay. So then the big deal is this maximum occurring when t equals 1. So that's pretty useful. Do we want to do this? It feels like there could be two answers here. Do you have any idea? Like, did you know if they're gearing more towards like sine or cosine on these?
I put cosine on like this wasn't the exact, this was the practice exam that we're doing right now, but on my exam I got it right and I put cosine. I think that was the other attachment I sent you.
So the reason cosine makes the most sense here is cosine starts high and goes low, and it's got a max right at the beginning, which corresponds to this. So we can change it to t minus 1 right here, and that's a right shift of 1, but it also gives you the max right there, because that's where it starts. The starting point is the max, and then that also answers whether it's plus or minus, because it's positive because sine starts high. Cosine starts high, and that also answers that part. And so that's why I'm trying to like find out a little bit more before I just, because there's actually multiple answers here to this. But this would answer.
Yeah, the right answer was cosine, because I have the answers to the practice exam. I'm looking at it now.
Oh, good. So you have to be able to to work through this, and this is a much more challenging problem than you've seen in past courses, but it's not impossible. You have to just work through it with parts that you know and don't know. But yeah, this is essentially what you would do.
And he put the like plus 3 first, like 3 plus 4 cosine. Yeah. I mean, it doesn't really matter though, right?
It does not matter. That's an older way of doing it. I'm making a guess. Your instructor might be older, but some books do it that way. Yeah, it doesn't matter. Really doesn't matter.
Okay.
All right. So in terms of sketching a graph, though, that's quite a bit harder. Are you doing these by hand, I'm assuming?
You're just supposed. Well, on the real exam, I think I sent you this page also. He gave us the graph and you just had to mark like where's the phase, where's the amplitude.
Yeah. Yeah. So you're gonna have to the ideal way to graph it is actually to start where there's a min or a max. So there's a max at 1, and that helps us to figure out how far out to go with this. Mm-hmm. And that's the question, is like, well, how accurate does your instructor expect you to be with these? Because a cosine starts high, goes low, and then comes back. Now we know the average. We know the average is 3. So actually, this isn't right. I apologize. The average is 3. That's your center line. I gotta give myself more room to do this. So the center line is at 3. I still haven't given myself enough room. Okay, there we go. So that means that's the midpoint, but it starts, the peak. Let me write this over here. The peak is the average plus the amplitude, and then the valley is the average minus the amplitude. So in your problem, that's 3 plus 4. And then 3 minus 4, so up at 7, and then it goes all the way down to minus 1 down here, and then so that gives us, that sort of frames this. You're supposed to go out 1 period, and your period is 5, so you go out 2, 3, 4, 5, 6. So it has to return to that point there. And then you've got to hit all the other points. So you got to recognize cosine comes down, and then it hits, well, actually, I'm sorry, it would hit there and then come back. So that center line, you treat that center line kind of like your old x-axis when you do this, and you get something that looks like this. Did I not? I missed some points here. Sorry. 2, 3, 4, 5, 6. Why is this off? Oh yeah, there it is. That's not it. Right there. And then, okay, so I'm messing up here a little bit on this, but
I don't think it's
you got to get sort of the right shape. One,
yeah,
two.
it's probably not gonna be like where we have to draw it anyways. It'll probably just be like where we have to mark it like on the test. Because what he does basically, if you don't get a topic right on the first test, it'll show up on the next test, which is why I'm going over this again.
Oh, good.
So yeah, it'll probably be similar to the other attachment I sent to you, where he gives us the graph and we just have to mark the backs and periods, that type of thing.
Yeah. Okay. So we've really nailed this one. Can we move on to this solving an exponential?
Yeah.
Okay.
And that's the one that I got wrong. Well, yeah. So we could do maybe both these on that attachment that you're working on right now, and then the other one, because the other one is the one I actually got wrong.
Sounds good. Sounds good. Okay. So the goal is to isolate the E. So if there's something out in front, you would divide it, or if there's something being added or subtracted, you would divide it, and so on. To do that, depending on the problem here. So we have E to the 5x plus 2 equals 28 over 6. You could reduce that to 14 over 3, but the key here is to get rid of the E, you have to use natural logarithm. Natural logarithm of both sides of the equation. Okay, and this is correct. It just doesn't look great, but it does undo the E. So on the left side, you get the 5x plus 2 equals natural log of 14 over 3. And then you're just solving for x. I mean, natural log of 14 over 3 is a number. You're going to subtract 2 from both sides. You're going to divide everything by 5. So you can divide by 5, and that's your answer. So the like this is completely correct. Now, if it were like a multiple choice test, it could appear in a few different formats. You could also go to a calculator and approximate the answer.
Okay. Yeah, we're not allowed to use calculators on the exam, so
Okay.
probably just leave it like that.
That's it, and that's your final answer. Do you want one like this to practice, or anything I could clarify on these steps?
This makes sense. The log one is the one. I obviously won't get the exact same question, so maybe we could do the log one and then like a few like that.
All right. For whatever reason, the next one here is about finding an equation through the line. So let me.
No, not the. It's
Do
a
you need
different
this?
attachment.
Let me go look. Oh, there it is. Okay, so let's go through that log one.
So that I know how to do. The equation through.
Well, there's no judgment. I mean, you got a lot to remember, and I have to look up things. I have to look up things all the time because there's only so much you can store. So this looks like the problem. The instructor is, I see. Okay, so the property here is if you have log base b of a minus log base b of b, it becomes log base b of a divided by b. So in words, a difference between logs, not within the log. This x minus 5 is within. Between logs is a quotient.
Okay.
So in terms of like what are you doing? What for your problem? The x goes in the numerator and the x minus 5 goes in the denominator.
Okay, because they have the same base.
Same base. They have to have the same base. Your problem will have the same base. It's a lot harder to do if they don't. So now that you have this, you're still not there. You have to undo the logarithm, log base 6. And to do that, use the 6 as a base for an exponent here, like this. And on the right, it's the same thing. So so you use the 6 as the base here, but it's also the base of the log, but it effectively cancels out. This goes away when
Oh, okay.
you undo it. And so you don't even need to show this step. Like your instructor wants to see this. They want to see this right here. So some students just go right to here, but your intermediate step is that you really are raising both sides using base of 6.
And then just solve for
Yeah, you have to
X.
cross multiply here. X minus 5 times, well, actually, let me do it this way so you can see it. You got to distribute in 36x minus 210. So you get the x's on the same side. So you subtract x from both sides. You add 210 to both sides, and you get 35x. And then you divide by 35. And that actually works. X equals 6. Wouldn't have thought that.
That makes a lot more sense. So I'm assuming that on this test, it's just going to be another, like, one of the log rules or another one of, like, the E rules. So
it could be that
know.
there's a plus here, and that changes it to a product instead of a quotient.
Yeah, so maybe we should run through a few of those, because I think, let me check which ones we covered. Okay, maybe we should just do the product one. I'm looking if I can find anything else that we went over. 2 point. Oh, okay, I did find it. So
You have one for me here?
we did log. Okay, wait, one of them was log base b of xy. Oh, that's the one that you're talking about, the product one, right?
Something like this. Is that?
Yeah. And then we also did log base p x to the, like, p power. Yeah. Or
I mean, these are properties, I think, is what you're
yeah,
trying to.
so like we just went over like all the log properties and like the laws of exponents and stuff, and so he'll make a question off of one of those basically.
Yeah.
So like if we could just go over like a few of those and like make questions through those, that'd be good.
Yeah, here it's a little bit tough to find, but I finally found one. All right, so because they rarely work out nice, but here's one: log base 9 of x minus 5 plus log.
Oh, I have some too if you want.
Okay, let's go through this one because it's a product, and then you can start sending over those other ones or so this is that other property. Log base b of a plus log base b of b, and a sum goes to a product, just like a difference goes to a quotient. So it becomes log base b of a times b. So whatever is in parentheses, you're gonna mesh in here. So this first line becomes log base 9 x minus 5 times x plus 3 equals 1.
Okay.
So now you have to be comfortable here undoing the log, and you're using this 9 log base 9 x minus 5 x plus 3 equals 9 to the power of 1.
So then the 9 log base 9 cancels out.
Yeah, and you end up having to FOIL this. So that's x squared plus 3x minus 5x minus 15 equals 9. Combine your like terms. And then you want to move that 9 over. So
And then you
two numbers that multiply to negative 24, but add up to negative 2. So that's x minus 12, x plus 2 equals 0. And this time you get 2 answers. In the previous problem, we just got 6. We should have checked it. I didn't think much of it. But when you get 2 answers, you should check them. You should say, okay, I wonder if they're both right. And you might even be wondering, well, how do I know? The logarithms have a domain restrictions. So the part inside parentheses has to be greater than 0. You don't need to know why. That doesn't necessarily preclude negative 2, but it most likely means that one's out. But we'll go back and look. But any questions on this? I mean, you got to be able to factor. This is prerequisite stuff.
No.
Okay, so you go back to your original, which obviously way up here, and when x is negative 2, let me do this in red. That way you can maybe wonder why it's in red later. So when x equals negative 2, you get log base 9 of minus 2 minus 5 plus log base 9 of minus 2 plus 3. So minus 2 plus 3, that's okay. But log base 9 of negative 7 is not. You can't take the log of a negative number. You might learn that why that is in calculus, but you just can't. It's just not allowed.
Okay.
And so that one's out. So that does not mean the other one is correct. It just means that that one is out. You could check the other one and see what you come up with, but it does work. The other one is okay.
Okay. I have a, I guess.
I didn't catch that. I'm sorry. You cut out just a little bit there.
Oh, I can send over. I have a few other examples, or I can just say them, I guess.
Yeah, either way, we'll see how good our communication is here.
Yeah, sorry, it's kind of loud, but I'm like in the here. So 3e to the 5x equals 12 is one of them.
Okay.
And then log base 2 x plus 2 equals 5.
Like this?
Yeah. And
okay.
then the last one, I have one more.
Yep, keep going.
Log x plus 2, like no base, plus log x minus 1 equals 1.
Like this?
Okay, that's it. Yep.
Perfect. Okay, we should do this one first, the last one, just because it's most like it. Okay. I'll give you a chance to also work one out. Now, when the base is not given, the base 10, is 10. Right? Yeah, base is 10, and that's needed here. It's not 0. It's not 1. It's not pretend like it doesn't exist. It is there. That's actually a good question to ask your instructor why they don't put base 10 when they need to. So this, this one though is just like the previous one. It's a product. So you're gonna get to this line right here, and I'd like you to try solving it from here if you're willing. And okay, you can talk about it at the end if you've got some questions. But go ahead and take a minute or two to figure that out. All right.
Okay, I got x equals -4 and 3.
Okay. And have you checked either answer?
No,
Okay, so you definitely
kind
want
of
to
forgot.
check. Definitely want to check
So
because
just plug it.
yeah. And start with the negative one. That's the most
Which
likely one.
which line do I plug it back into?
The beginning, the original function.
Okay.
Now the actual you're looking for a problem. You're not necessarily like trying to verify that the left looks like the right. You're really just saying, oh, I can't do the left because it's negative logarithms.
Okay, so a negative, like x equals a negative number will almost like never work then.
Well, so you've had a test from your instructor. Do they like to test on the exceptions? The weird cases?
No, I give us not really.
Probably not. I mean, you probably can do that, like, but yeah, it's
Okay, so 3 works then.
3 does work.
Okay.
Any questions on that? And we've done a couple of examples. You might get the difference where you got to divide. And when we looked at that one, it worked out nicely, even though there were x's in both the numerator and denominator. You ended up just getting one answer. Let's go to, sorry, no, I'm scrolling around too much. Let's go back to, we'll go reverse order here. We'll do this one next,
Okay.
the log base 2 problem. This one's actually much easier than what we just did. Because you've already reduced it down to a single log. So notice I said earlier, you want to isolate the e, you want to isolate the log, you want to isolate the ln. Like it's all the same strategy, and you already have done that on the left. It's already isolated. Like let's say there was like a 5 out in front, you would divide by 5. You want to get it all by its lonesome self here, and then you undo whatever it is, the e, the log, the ln. You undo it. So here you undo it with the base of 2.
Okay.
This is very formal the way I'm doing it. You don't have to do this. You can say, oh, when I undo it, I get just x plus 2, but you got to remember it's 2 to the 5th. It's not 5. Because notice if you wrote 5, you'd get a number that seems like it works, but it's not 5. It's 2 to the 5th, which is 32.
My professor is a stickler for showing your work, so I probably do have to show that middle line.
It's very formal, and I would do whatever they want. That's what college is all about. Give them what they want. Because what you want is at the end of 3 or 4 years,
Doesn't
you get a
matter.
degree. Yeah.
That's 30. Okay.
It's 30. Okay. Would you like one like this to try on your own?
I'm sure.
Okay. Let's go 2 log base 3 x minus 1 equals 6.
So in this case, because you have the 2, do you just divide it out first?
Yes, divide it out first.
Okay.
And you can carry out from here, please.
Okay. Uh, 26. What I got. Oh wait, 28. Sorry, 28. I think you're muted, or I can't.
Yeah, sorry about that.
Okay.
Yes, but yeah, 28, not 20, 26 there. Good.
Yeah. Just wrote it wrong.
Do you have any other classes that you really like? Like maybe you're running.
I really like my psych my psych class is really interesting. It's called Brain and Behavior, and it's specifically for like neuroscience majors, so it's fun.
Have they asked or requested you guys participate in any studies they're doing?
Yeah, we have to do 4 hours of like research, participate in research studies.
And have you done any of that yet? Because it's always a little weird. At least that was my experience.
I've done like some online ones, but I'm going into like, I think next weekend I'm doing like someone in the lab where they like they're measuring like my stress levels or something like that.
Okay. Yeah.
Yeah.
There's so many interesting ones that they refer to that you could never do now.
I know.
So, all right. So this one here again, you're gonna isolate the E. So you have to divide by 3 on both sides.
Okay.
And it doesn't always have to work out nicely. Like if that were 13 instead of 3, you just have a fraction, and that's okay. So to undo E, so maybe I should make this clear. If you have a log base B of X, you undo it with B to the log base B of X. If you have ln of X, you undo it with E to the ln of X. And if you have E to the X, you undo it with natural log of X. This is almost everything. So for formal, being very formal here, showing all your work, you take the natural log of both sides of the equation.
Right. And so then the
so,
LNE goes away. Yeah.
Yeah. Now there's even an intermediate step here, and that I'm reminded of that because some instructions like the property is that the 5x comes out in front. This is like the truly like everything in here, and then somewhere you'd want to say that the natural log of E is 1, so it becomes 5x times 1. I mean, that's kind of extreme, but that is the full of everything. I mean, I doubt.
So then it's just ln 4 over 5, and you just leave it like that.
That's your final answer.
Okay.
There's nothing more you can do from that point. Let me give you one here to try on your own. Let's go E to the 3x minus 1 equals 2. Go ahead and solve for X.
ln 3 over 3. I think you're muted again.
Yes, you got it. Yes.
Okay, perfect.
All right. So there's a lot more we can cover, but
yeah, I think that's good for that. Maybe we should move to the what was it? The sample exam. That's like derivative stuff.
Yes.
And that's like mostly what the test will be on then.
So I'm seeing limits to start out. Is that okay if we start there?
Yeah, it's yeah, we can just start at the beginning. I haven't done any of it, so.
Okay, it starts at question 5.
Yeah, it's like topic 5, so.
Oh.
That's right.
Okay.
It's a weird system. It's like a mastery-based grading system. So it's a bit odd.
Yeah, I see that on the cover sheet now. Topic 1, 2, 3, 4, 5, 6,
Yeah.
7, and yeah.
So basically, like I didn't master 2 of the topics on my first test, so those 2 topics will be on my next test in addition to the 4 topics for this test.
Is that just the math class, or are the other?
No, it's just my math class.
Just your math. Okay. All right.
And it's just this like one professor that likes to do it that way. I don't know why, but.
Okay. So the first thing you always try with limits is you just try the number. And you just put the number in for X. You just plug it in, and maybe it works, maybe it doesn't. 3 squared minus 16 over 3 minus 4, 9 minus 16 over -1. And you end up getting you end up getting 7. So what you're looking for to decide if it doesn't work is division by 0. Okay, but more generally, it would be 0 over 0. Division by 0 is one possibility. 0 over 0 is the other. And we'll probably see that in the next problem, and we do.
Also, that's it, because you just get the 7, that's your answer.
That's your answer, yeah. And really, like, let me do something else here. Why did that go over there? Okay, the formal way of doing it, it really is you should have an equal sign there, and it should all be in line, in a line like this. I know you don't have room. Well, you might have room. You might rewrite it. Now, for question B, I'm going to show you how to do this more formally, so that you're maximizing the grade here. So this time when you try 0, you get 1 minus 0 squared over 0 squared, which ends up being 1 over 0. Okay, and this is bad. This is bad. Okay. So the next kind of like, so this is one of those problems, is division by 0, which doesn't work. What you want to do is typically you go to factoring the numerator and denominator. That's one sort of strategy. And so you have to rewrite the limit. Limit as x goes to 0. The numerator is difference of squares.
Okay.
Okay. But this actually doesn't help you in this problem. So the reason you would factor is you're looking for a cancellation.
Mm-hmm.
Okay, so since there's no cancellation on this, you've got a problem. You've got like, it's like now there's uncertainty about what to do next. So this is where I need to know more about what you're allowed to do or not do. You said no calculator, but you could graph this. You could graph this function, believe it or not. And that is one approach to doing this. The other approach,
I don't think he wants us to graph it.
okay.
I don't think we did that in class. I'm trying to remember if we did. Let me look at my notes, but I don't think we did.
So if that's not allowed, we'll move on to another option.
I'm sure it's allowed, but I don't know if that's the way he wants us to do it. You know what I mean?
Yeah, so the next thing is to take the limit as x approaches 0 from the left and then from the right. Okay, and what you hope for is that they approach the same value. And if you have your notes, I mean, it would be helpful to know if this was what you ended up doing.
Yeah, I'm trying to look for it right now. Okay, well, when we got one that was like an indeterminate form, it was one that had a cancellation.
Yeah, and so this one's not indeterminate form. It's a vertical asymptote, so it's not quite the same. That's why I wonder if this is a mistake. Yeah, but whatever. We can still do it. It's just this is a much harder problem than I think it was intended.
Yeah.
So when you approach 0 from the left, you want to think of x being approximately minus 0.00000, a bunch of zeros and then a 1. So like literally just a tiny bit left of 0. And then what you do is you attempt to evaluate it in here, but you're looking at the sign. Okay, so notice the number is negative. It becomes 1 minus a negative number becomes a positive. So this 1 minus x is effectively positive. 1 plus a negative number like this is also positive. So you have a positive times a positive. And then you go to the bottom here. When you square a negative, it is also positive. So this is kind of showing your work, but the result is that this goes to positive infinity from the left.
Okay.
And then you do the same thing over on the right. So you presume again that x is approximately like 0.0000, a bunch of zeros and then a 1. It's just a tiny little bit right of 0, but it's positive now. It's just a little bit right of that number. And then you again try that in here, and you're looking at the sign. So 1 minus 0.00001 is a positive number. 1 plus a positive number is also a positive number. A positive number squared is a positive number. So this 2 also goes to positive infinity. So for the limit, you only have to prove that the limit from the left and from the right are equal. And we have done that. They approach the same value. So your answer here is positive infinity. And then the question is like, is this sufficient work to justify it? I would say it is.
So if it was a case where it was positive infinity and negative infinity, would the limit just not exist then?
That's correct. It would not exist.
Okay. Okay.
So I'll just mention this because I have no idea. They used to teach it. There's what these call these power terms that dominate near asymptotes. And there's a way to figure them out. I don't know that that is what you're doing, but anything like that sound familiar?
I don't think so.
Okay.
Maybe we should do one that like has a cancellation, because I'm thinking that will be like a more likely case.
Yeah, so let's do that. Let's go with the limit as x approaches a number that I will tell you in a moment. Let's go x squared minus 9 over x squared minus 3x minus 2. And let's go with 3. Yeah, 3.
Okay.
So you would start by just trying the number.
Yeah. I'm gonna mute myself.
Except I didn't give you the right number. We'll go -3. Why am I struggling here? Oh, that's why. Sorry, this is wrong. Okay, now it's going to work. Okay, so 3 squared minus 2 times 3 minus 3, and you end up getting 0 over 0. This is indeterminate form. It must be both zeros on the top and on the bottom.
Okay.
So you're like, what do I do next? Well, you factor the numerator and the denominator.
Bottom. Yeah.
And then you hope that there's something that cancels. And the x minus 3's cancel. So because you're being super formal, you continue writing the limit down the left side of the page. And then you always go back to your original strategy where you try the number. So you would plug in 3 plus 3.
Yeah.
And you're like, oh, it works. And that's the intention of these problems.
Okay. I think we can go to the next one.
Yeah, this one's really a test of your ability to be very formal, write it out correctly. You don't have to justify your steps usually, but you have to break this apart. You can't just say, oh, the answer. You can't just say, oh, the answer is 7. Like that's or 3. You're like you can't just say, oh, here you go.
Right.
The first thing is that you can break this apart into the sum. You can break apart this into I don't want to say this, the two terms. You just break them apart with that. And then the next thing you can do is you can bring the 3 out. You can always bring coefficients out. And that's what I was mentioning. Like sometimes they want you to justify each step. It's kind of like when you're in geometry, you're doing proofs. It's kind of a pain, but there. And if you want to, you can bring that 4 out as well. It actually is less important. But we'll just do it anyway for that. So now this, you're trying to get to this. Like you're trying to get somewhere where you can use the fact that sine x over x is 1. And that's when you're allowed to be like, okay, that's 1. And then when x approaches 0, you're plugging 0 in for x. So 0 squared, like that. And then you get 3 plus 0, which is 3.
Okay.
I think
That
I
makes
would
sense.
ask the instructor though, because this word here carefully, it implies like he's looking for a certain set of sequences. I would ask, do I need to show, limit properties for each step?
Okay. He usually posts like a video of him answering the practice like exam. So I'll find out in like a few days, I guess.
Okay. Yeah. Have you gone into your office hours to see any of your instructors at this point?
Yeah, I have. I went to his once, but it was like so packed in there. His office is like really small. Wasn't that helpful?
Okay.
Because like everyone struggles with this class because it was the last topic because it's a very weird like form of math class. It's like biocalculus, like I don't know. So everyone has trouble with it that takes it basically.
Yeah, even just going, maybe he saw you. He said, "Oh yeah, she's in that class." Like it's always good because you're coming from an environment where they're supposed to get to know you. They're supposed to know your name and what's going on.
Yeah,
But like
exactly.
it's completely different now, and it can only
Yeah.
help. But yeah, I mean, you may find that I mean, I've seen instructors have like Saturday office hours and like nobody goes. But
Yeah.
if you can make an effort to go, I think you'll see some value. So we'll probably a good place for stop here, starting at
Okay.
topic 7, and we'll just keep
Or
working
6,
through
right?
6. Yes,
Yeah, because we only
yes,
did 5
yes,
today.
6. Yeah. You should have some confidence though. All of this is review. It was probably about a year ago you were doing this, but it is all review.
Yeah.
For you at this point.
It is. I feel a lot better about this test because of stuff that I've learned and
Excellent. So I will send you the notes here shortly, and I guess we're doing another lesson on whenever
Saturday,
Saturday.
I think.
Saturday, yeah. Great. So we'll just pick
Yeah.
up here.
Okay.
All
Thank
right.
you.
Hope you have a great rest of your day. Bye now.
You too. Bye.